given y1 equal to 4 sin 4 naught 4 pi t. Omega 1 is 2 pi L1 4 naught 4 pi. N1 here is other wave equation 3 sin 400 pi t. Omega 2 is 400 pi. 2 pi N2 is 400 pi. N2 is 200 H. So heat frequency is N2 minus N1, which is 2H. So maximum intensity A1 plus A2 whole square, that is 4 plus 3 whole square, 49. Minimum intensity A1 minus A2 whole square, 4 minus 3 whole square is 4. So second option. The difference in number of wavelengths when yellow light passes. The difference in the number of wavelengths when a yellow light propagates through air and vacuum of same thickness. Let us consider this as air, vacuum. Generally, we consider same, but he given refractive index of air as this. So, velocity of light in vacuum. So, velocity of light in medium is C by mu. That is, here medium is air. Velocity of light is this. Similarly, refractive index of wave in vacuum, refractive index of wave, wavelength of wave in vacuum, wavelength of wave in air is wavelength in vacuum by refractive index of air. So since wavelength is small in air, more number of waves, that is counted as one wave. The more number of waves, your wavelength is more, here it is one wave, two waves like that. Here less waves pass through this thickness. This distance is covered by, we don't know how many waves, each of wavelength lambda. Let us assume here it is n lambda vacuum. According to information, he told that 6 waves, difference is 6 waves lambda in air. So n plus 6 of lambda in air is equal to n lambda in vacuum. N plus 6 lambda in air is lambda in vacuum by refractive index and lambda v. So from here, n plus 6 by n, 1.003. So here it is 1 plus 6 by n point. So 6 by n is 0.0003. Then here is 6 by 0.003. T0. 6, 1 plus 6 by n is this. Then here is the thickness he is asking. This is 2 into 10 power minus 4. Thickness will be n here is 2 into 10 power minus 4 into 6,000 angstrom units, 10 power minus 10. So here it is 12 into this 10 power plus 4, 10 cube, 10 power minus 3. It's nothing but 0.012 meters or 1.2 centimeters. So third option is correct. Here for Brewster angle, so Brewster angle is angle where incident ray unpolarized light becomes polarized for some angle where angle of this reflected ray and refracted ray are mutually perpendicular. This is called polarizing angle or Brewster angle. That theta is tan inverse mu. Critical angle means where ray of light passes from denser to rarer, it gets totally reflected. So that angle is with the normal C. So mu into sine C here is 1 by mu. Sine C is 1 by mu. Here it is mu is tan theta. So 1 by tan theta, which is sine C is cot theta. C will be sine inverse cot theta. Here he is asking only beats. Omega 1 is 1005. N1 becomes 500. Omega 2, which is 2 pi N2, which is 998 pi. 499. So N2 will be 499 H. It is 500 H. Number of beats is 1. So here, once this is here is one distance between the slits is D. Here is screen. So if so ray of light passes through it, generally we get central intensity is maximum. Right at this point. Once in the path of light, glass plate is introduced. then this bright fringe shifted by a distance y, that is nothing but mu minus 1 into t. T1 is thickness of one plate into capital D by D. Now what he says, central fringe is not shifted means through others, here light is passing through this source also, then there also shift occurs because of it, that y1 and y2 both are same. So finally central fringe will not shift, that is so here it is mu minus 1 into t1, here it is he given refractive index. Central fringe will not shift. If y1 and y2 are equal, that is mu1 minus 1 into t1 is mu2 minus 1 into t. 1.5 into t1 is equal to 0.6 into t2. t1 by t2 is 6 by 5. A bar magnet is suspended freely in a uniform magnetic field. So then it has a magnetic moment m. It rotates by an angle alpha, then torque will be mv. The torque experienced by the magnet, if it is turned through an angle alpha towards the field, then torque will be mb sine alpha by 2, which is c2. And he is asking c2 by c1, mb sine alpha by 2 by 2 sine alpha by 2 cos alpha by 2. Get cancelled with half. Tube is arranged such that its length, breadth, and height along XYZ axis one of its corners is situated at the origin. Length of each side is 25 centimeters. The components of electric field along X direction, X is 400 root 2. Then flux coming out here through this electric field direction is this, area vector also in the same direction. Flux will be E dot A. Once they are parallel, so E here is 400 Newton. Area is 25 into 25, they are in centimeters. So here it is 100 425 times 25 root 2. Newton, here it is meter square per cubic. A parallel plate A parallel plate capacitor is charged. True charge is deposited. It is disconnected from the battery. Then charge remains the same after disconnecting from the battery. Also, charge remains same. And plates of the capacitor are moved away from each other. D increases, then potential difference, that is ED1, which is greater than ED. So potential difference increases. Now, after that, after separation of plates, again it is connected to the battery. Here it is V1. So V1 is greater than V. Then charge flows from capacitor to the battery. Here, in one row, there are N cells are in series. So each have a internal resistance R. Like that, N cells are connected, NR. So in this way, cells are connected in M rows. So then effective resistance is NR by M. So all these are connected to a battery, and then external resistance, capital R. So maximum current flows if internal resistance is equal to external resistance. Total number of cells in one row, there are n cells. In m rows, 64. Here it is internal resistance given, capital R also given. From here, n is 4m, m into 4m, here is 64, m square is 16, m will be 4. Once m is 4, nm is 64, n will be 16. Here it is wires of resistance. R2 minus R1 is R1 alpha 1 delta T. So this is about one wire. Initial resistance at T1 is R1. Once temperature is raised, its new resistance. R2 dash is R2 into 1 plus alpha delta T. When they are connected in series, initially this, so effective resistance is R1 plus R2 initial resistance. So temperature coefficient of effective resistance is alpha effective delta T, which is R1 plus R2, some new resistance. So here R1 dash minus R1 is the R1 alpha delta 1. Similarly, R2 dash minus R2 will be R2 alpha 2 delta T, which is R1 plus R2 alpha effective of delta T. So alpha effective will be R1 alpha 1 plus R2 alpha 2 by R1 plus R2. When to convert 540 grams of I set 0 to water at 0, we require 540 into 80 calories. But the hot substance here is, which is at higher temperature, equal amount. Availability is 5 grams of water at 50. When compared with the 0 degree centigrade, it has 540 into specific heat of water. So this many calories of heat is available. But to melt ice, this much is required, is less than 540 into 80, which implies total ice cannot be melted. The resultant temperature is 0 degree centigrade. The stopping potential is required to stop the photoelectrons emitted from a metallic surface is work function plus Ke maximum is C by lambda minus 5, which is that Ke maximum is E times stopping potential. For light, so metallic surface is not changing. Stopping potential changes means for a different wavelength, work function is same, stopping potential changes. So subtracting one from other, 1 by lambda 1 minus 1 by lambda 2 is E into Vs minus Vs dash. Let's see, here is 1240 electron volt nanometer, 1 by lambda 1 minus 1 by lambda. Here it is electron volt charge. So Vs minus Vs dash. At 1240 into 10 power minus 9, 1 by lambda 1, that is initially 1 by 4000 angstrom units minus 1 by 3000. 1 angstrom is 1 by 10 power minus 10 meters, or 0.1 nanometers. electron volt, that is nanometer, or let me write here 10 power minus 10, which is Vs minus Vs dash. So 1240 by the 12,000, 3 minus 4, Vs minus Vs dash. So Vs dash will be Vs plus 124 by 120. Here Vs is 0.82, it is roughly 1.03. We get 1.85 volts. For hexagon, so here circuit carries a current I. Regular hexagon means all angles are 60 degrees. So it will be 30 degrees, it will be 30. So then magnetic field at center calculated by using a formula mu naught by 4 pi d sin alpha plus sin beta. Here d is height of equilateral triangle, root 3 by 2a sin 30 plus sin 30, mu naught I by 2 pi root 3a, half plus half, which is mu naught I by 2 pi root 3a. Now, so once current flows like this at the center, the magnetic field will be perpendicular due to AB. Even B to C also perpendicular to the plane. Due to all finite segment, magnetic field direction is perpendicular to the plane. It is coming out of the plane. So net magnetic field is due to 6 segments, 6 into D, that is 6 into mu naught I by 2 pi root 3a. Here we get root 3 mu naught I by pi a. So first option is correct. A thin wire ring of 3 centimeter radius rests float on the surface of the liquid. To pull it here, this side, one film is one water layer is connected. Here, this side, one water layer. 2 layers are connected throughout the circumference. So here, surface tension, force into, here T is this. So force required is T into L. Here L means throughout the circumference, 2 pi r, since 2 layers are connected. One is inside the ring, other is outside surface. That is T into 4 pi r. So T is asking 4 pi radius is 3 by 100 is equal to 30.1 into 10 power minus 3. Here T is equal to 30 into 10 power minus 1 by 4 pi into 3. So here it is 10, 1 by 12 roughly. So it is 80 into 10 power minus 3. First option is suitable. Here it is LCR circuit. So here EMF alternating EMF is equal to VR square plus VL minus VC whole square. So 100 square, sorry, AP square, 100 minus 40 square, which is 100 volts. So electromagnetic radiations. So electromagnetic wave E naught sine omega 1t plus sine omega tt or radiations described by an equation. So here it's a combination of two different waves, 2 pi n1, which is 2 into 10 power 15, other is omega 2, 2 pi into n2, which is equal to 6.28 into 10 power 15. So here corresponding frequencies which we find 10 power 15 by pi. Here it is 2 pi get cancelled 10 power 15. So obviously higher frequency wave has maximum kinetic energy. So that E is equal to H nu 2, H n2. H value is 6.6 into 10 power minus 34. And that frequency is 10 power 15, which in turn 10 power minus 19 joules. So he given work function in terms of electron volt. So 6.6 into conversion, 1.6 into 10 power minus 19. 16 force, 6420. So roughly this electron volts. So incident energy is this, and work function is this. Kinetic energy maximum will be 4.25 minus 1.5, which is 2.625 electron volts. The current in a circuit containing a battery is connected to 2 ohm resistor. Battery has an internal resistance small r, E minus IR, which is equal to I into capital R. So that is E minus I here 0.9 amperes. Smaller we don't know. 0.9 into capital R is 2 ohms. Similarly, 0.3 ampere current flows when external resistance is 7 ohms and 0.3 ampere current flows. Internal resistance subtracting one from other minus 0.6 R is 1.8 minus 2.1. R here is half. Internal resistance 0.5. So here half-life is, we have a formula. Mean life, we have a formula. Half-life period of radioactive element X. 1 corresponding wavelength lambda x is same as mean life of other lambda y. Initially, both has same number of atoms, since which has more decay means Tx by Ty if you calculate. And what he given is half-life period. They are same. So same in the sense 0.693 by lambda x equal to lambda y. So lambda x by lambda y is 0.693, which is 1 by 1.4. Lambda y is 1.4 times. That means lambda y is 0.969. Lambda x by lambda y is this, which is 1 by 1.4. So that means decay constant for second element is more, implies y decays faster rate than x. Here in transistors, we have a NPN transistor, PNP transistors. So this transistor we use for the purpose of amplification of input signals. So in NPN transistor, there are three modes of amplification. One is common base, common emitter, and common collector. Generally, we prefer common elector mode. In this, amplification factor is beta. In this, amplification factor alpha. Now here, common emitter amplifier. So amplification factor is beta. So basically, amplification means output current by input current. Here you have voltage amplification. The output is in beta into V R output by R input. That is 10. R output is 5000 by 2000. So it is 125 units. Amplification factor is equal to V naught output by V input. So peak value is given amplification factor into V input. Amplification factor is we calculated 125. V input 10 into 10 power minus 3, which is minus 1.25 volts. So from this, TV broadcasting to transmit picture as well as sound. It is audio, that is video signal has to be sent to the receiver who is at larger distance, far distances. So here, for that purpose, modulation is compulsory. There are three types of modulations: amplitude modulation, frequency modulation, phase modulation. But for TV broadcasting, is amplitude and frequency modulations. Can we use C modulation for both means? We cannot. So here, if they travel through same modulation, that is either amplitude or frequency modulation, there is a possibility of mixing the signals. So to overcome that, we sent these base signals through different modulations.